Hey everyone, we are going to be talking about equations of circles today. Now, you know how to draw a line on a graph, right? You know that the equation of a line is y equals mx plus b. And you know how to graph a parabola, right? A quadratic, because you know those equations. Now, what's the equation for a circle? It's going to look a little different than what we're used to. It's not like y equals something, but let me just write this out for you and you can get an idea. Now, when you graph a line, you need to know the slope and you need to know the y-intercept. When you graph a circle, you need to know the center and you need to know the length of the radius. So just like we use m for slope and b for y-intercept, who decided those? We're going to use h and k for the x and y coordinates of a center of a circle on a graph. And then obviously r is radius. So here's our equation. It's going to be x minus h squared plus y minus k squared equals r squared. Does this look familiar to anybody? To me, it reminds me of the Pythagorean theorem with a squared plus b squared equals c squared. And that's kind of where it comes from. It's a derivation on the distance formula, which is basically a derivation of the Pythagorean theorem. So what I mean by that is if you have a circle, right? And here's my center, 3, 2. If I want to get to some point on the circle, you would make like a right triangle to figure out, oh, where there's my radius and there's my side lengths. Well, these lengths right here, well, if it's 3 over on your x-axis, it's x minus 3. And if it's 2 up on your y-axis, it's y minus 2. And then the radius here gives us our value. So if I wanted to write the equation of this particular circle, well, I can clearly see that the radius in this circle is, let's see, 1, 2, 3, 4 units long. And then if it's 3, 2, that's my h and my k. So this circle would have an equation of x minus 3 squared plus y minus 2 squared equals 4 squared, which is 16. And that's it. There's nothing else to do. You don't need to solve for y. You don't need to FOIL this out and get rid of the squares. Like, you don't need to simplify. That's it. You want it in this form. Okay? So in your toolkit, I want you to add this definition to equations of circles. It should be on the last page of chapter 10. There's a box for that. And I'd maybe either add this example or some of these examples in number 1. Now, we're going to go through a lot of examples just so you can really get this down. This equation is what you're always going to be coming back to, though. This is where you're going to go to do the problems. So for each of these problems, we're going to write an equation for the circle. And we need to know 2 things. We need to know the center coordinate and the radius. Now, for this first one, it gives me the center is at -2, 4, and the diameter is 4. If the diameter is 4, that means the radius is half of that, which is 2. Just like when you found area of a circle, you need to know the radius squared times pi. In all of these, you need to know how long the radius is. So if they give you diameter, turn it into the radius. So let's plug this in. -2 is going to be my h value. 4 is going to be my k value. And I'm simply going to substitute them in up here, right? All these values are going to get substituted in. And then I'm going to simplify just a tad. So I've got x minus -2 squared plus y minus 4 squared equals 2 squared. Now, the only thing I'm going to simplify is if there's a double negative, I'm going to turn that into a positive. So it's really x plus 2 squared, and then plus y minus 4 squared. And then I'm just going to simplify 2 squared is 4. And that is our equation. This isn't something that's easy to put into a graphing calculator, so we just have to graph them by hand at this point in our lives. All right, if I look at the one directly below it, the center is at the origin. Well, the origin is the coordinate 0, 0. So if I did x minus 0 squared plus y minus 0 squared equals, if the radius of the square root of 3 is the square root of 3 squared. All right, let's clean this up a little. X minus 0, that's just x. Y minus 0, that's just y. Square root of 3 squared is 3. There you go. If you're feeling good about this, press pause and do C and D on your own. Otherwise, follow along with me. After you do them on your own, obviously, press unpause and you can see how you did. So if my center is at -3, +3, I'm just going to skip. It's essentially changing the sign. So if it was -3, it becomes a +3 because you're subtracting. If it's a positive, it's a negative. If the diameter is 12, that means the radius is 6, and 6 squared is 36. All right, for this one here, I've got x plus 12 squared plus y plus 1 squared equals the square root of 8 squared, which is just 8. I went through those really quickly, but it's because I'm using this formula and I'm just substituting in the values every single time. The common mistakes that I see are forgetting, like if it's plus or minus in here, it's essentially just the opposite of whatever the center points are. And then forgetting to put the squares out there and then forgetting to square the radius. All right, if we know the equation, can you graph it? I'm not expecting it to be perfect, but I do expect you to have at least the correct center and the correct radius. So if this is my equation, if it's x minus 2 and then y plus 3, that means my center is going to be at +2, -3. So +2, -3, I'm counting by ones on all of these graphs. It's a 1 on the scale. And then this is the radius squared. So the square root of 4 is 2. So that's my radius. So then what I'm going to do is I am going to count out from this center point 2 spots. So like to the north, south, east, west. So up, down, left, right. And that's going to give me a good idea of where my circle is going to be. Okay, so it's not perfect, but it's close enough. And you get better with practice. This one, if it's x minus 3, it's going to be +3. There's nothing with the y squared, so that tells me that coordinate is going to be 0. The square root of 3 squared is just 3, because 3 squared is 9, square root of 9 is 3. So that's my radius. So if I've got 3, 0, so I'm right here on the x-axis, and then I count out 3 in each direction to get an idea of where my circle is going to end up. Next one, we've got x squared and y squared. So I know this one's going to start at the origin because there's nothing subtracting or adding. So I've got the origin here. The square root of 16 is 4. So that's my radius. Remember, we're square rooting. We're not dividing by 2. So that's another common mistake I see. So the square root of 16 is 4. So you count out 4 in each direction. 1, 2, 3, 4. 1, 2, 3, 4, and you make your circle. Isn't she pretty? All right, the next section is still writing the equation for this circle, just like we did in number 1. The only difference is this time they give us the graph. So from the graph, we need to identify the center and the radius, and then once we know those, we put them into the equation, just like we did in the first one. So this circle has a center at -3, +3. So that's my center. And it has a radius of 2. All right, so let's plug that into my equation. X plus 3 squared plus y minus 3 squared equals 2 squared, which is 4. All right. Let's go to the one to the right. This has a center at 0, -2. This has a radius of 3. So it's going to be x squared plus y plus 2 squared equals 9. If you think you've got this, press pause, try C and D on your own. Okay, for C, this one is started at the origin and has a radius of 3 again. So x squared plus y squared equals 9. This one has a center at 1, 0. Radius is 3. So it's going to be x minus 1 squared plus y, oh, I don't even need that, plus y squared equals 9. There you go. All right, let's kick it up a notch. This next page, I'm going to suggest you use your own graph paper. If you don't have graph paper for some reason, the third page of the document was these like plain blank graph grids, so you can use those if you need to. So what we're going to do here is we're still trying to find the equation of the circle. So let's rewrite it just so we have it. X minus h squared plus y minus k squared equals r squared. So we still need the center, we still need the radius. So we have a circle that has a center at -2, -7, and the radius with an endpoint of 0, 7. So they're giving us the center, but they're not specifically telling us how long the radius is. We can start by filling in the first part of the equation. We get x plus 2 squared plus y plus 7 squared is going to be equal to some r squared, which we don't know yet. If you were to graph this and see what it looks like on graph paper. So I need to make it big enough. Here's my y-axis. Here's my 1, 2, 3, x-axis. Can you see that okay? Yeah. 0, 7 is 1, 2, 3, 4, 5, 6, 7. And then -2, -1, 2, 3, 4, 5, 6, 7. So that's my center right there. And then if you were to connect these 2 points, that would represent the radius of the circle. And we need to know how long is the radius squared. So you have 2 options for how you can do this. First option, since you have a graph, you can do the Pythagorean theorem, right? If you turn this into a right triangle. So this would be, let's do this here. This is going to be 2 squared. And then 7 and 7, that's going to be 14 squared. And if this is my radius, that's going to equal my radius squared. 2 squared is 4. 14 squared is 196. Equals my r squared. So 200 equals the radius squared. So the radius is the square root of 200. But I don't need to know the radius. I need to know the radius squared, which now I do. So I can plug that in and just say x plus 2 squared plus y plus 7 squared equals 200. Now say you didn't want to graph it. You don't need to. As long as you have the first part of your equation, if you pick a point that lies on the circle, which this point does, it's on this invisible circle. If you plug it into the x and y values of your equation, it's going to equal some r squared value. So let me show you. If I'm going to use this equation here, so I've got 0 plus 2 squared plus 7 plus 7 squared equals r squared. So this gives me 2 squared. This gives me 14 squared equals r squared. And now I'm back to that step right there. So this is just doing it by graphing. This is doing it, this is doing algebra. This is doing by graphing. You do you. All right, let's look at the next one. We want to find the equation of a circle whose diameter has endpoints at 0, -3, or excuse me, -3, 0, and 3, 0. So in this case, they're not giving us either the center, nor are they giving us how long the radius is. So I'm going to graph this and get a good visual. I have -3, 0 right there, and 3, 0. This represents the diameter of my circle. Now, the center of the circle is the center of the diameter. This one's really easy to see visually. My center is going to be at the origin, 0, 0. And then now that I can see where the center is and where the radius is going to end, I can see that my radius is 3. So this was one where graphing really helped. And I can write my equation, x squared plus y squared equals 9. Now, they're not always going to be that easy. Look at the next one. We want to find the equation of a circle whose diameter has endpoints at -4, 3, and 0, -5. Okay, let's graph this again. -4, 3, 0, -5. Draw my axes. I'm counting by 1 on all of these axes. -4, 3, and 0, -1, 2, 3, 4, 5. Okay. That right there is my diameter of my circle. Oops. Now you can see it. There's my diameter. I need to find the center point. So essentially I need to find the midpoint. A few chapters ago, we learned how to find the midpoint of a segment. We wrote the formula down in our toolkit. So if you want to flip back in your toolkit now to find that equation, it's essentially just averaging the two coordinates together. So what I mean by that, let me go back down here. We want to find our center, aka the midpoint of our diameter. So we're going to use this formula. You're going to add your two x's and divide them by 2. And then you add your two y's and divide them by 2. It's called the midpoint formula. All right, so we can just call this x1, y1, x2, y2. Since we're adding, it doesn't matter which one is which. So let's add -4 plus 0 over 2. I didn't mean to put that there. And then let's do 3 plus -5 over 2. That's where I want the parenthesis because it's a coordinate. So I get -4 over 2 and -2 over 2. That reduces down to -2 and -1. So that is my center. I can see if I did it correctly by graphing, is that point even on the diameter and does it look like it's about halfway between the two endpoints? -2, -1. Look, it's on the line and it looks like it's about in the middle. Awesome. So we can go to this step where we write the beginning of the equation. So I get x plus 2 squared plus y plus 1 squared equals r squared. Now we're back to what we did up here. So I can pick either of these endpoints and plug them in for x and y, or I could make a Pythagorean theorem problem to get my r squared. So if this is 2, 1, 2, 3, 4, it'd be 2 squared plus 4 squared. So 4 plus 16 is 20. So 20 would be the radius squared. If I wanted to do it by algebra, I would say, I don't know, let's plug this point in, why not? So 0 plus 2 squared plus -5 plus 1 squared equals r squared. So 2 squared plus -4 squared, same problem, 4 plus 16 equals r squared. So then you just rewrite it. With everything where it goes. Let's circle my final answers so we can see what it looks like. Okay, let's look at the next one. Which of these points lie on the circle? So not in the circle, not outside of the circle, literally on the circle. The same way you would tell if a point was on a line, if you plug it in for x and y, if it makes it true, then it works. This, you could graph it. You really could. The only problem with this one is that your radius is 10. So So it's going to be a pretty big circle, and I don't really want to graph a big circle like that. So I'm going to do some algebra. Now this circle has a center at 4, -3. That's my center. So if this is the point 4, -3, that can't be on the circle. That's literally in the circle. Okay, so that one's not going to work. Let me show you what I mean about testing the math and see if it works. And then I'll do one, and then you'll press pause and you'll do the other 3 and see if it works. For every coordinate that I'm testing, plug them in for x and y and see if it equals 10 squared. Does it equal 100? If I have -4 minus 4 squared plus 3 plus 3 squared, we want to know, does that equal 10 squared? Just put a little question mark because we don't know. -4 minus 4 is like saying -4 plus -4, which is -8 squared. 3 plus 3 is 6 squared. Does that equal 10 squared? -8 times -8 is 64. Plus 36 equals 10 squared. 100 does, in fact, equal 100. Since it's true, it's on there. Now, press pause, do the other 3. Let's look at this one. If I have -6 minus 4 squared, plus, again, 3 plus 3 squared, we want to know, does that equal 10 squared? -6 minus 4 is -10 squared plus 6 squared. So 100 plus 36 does not equal 100. So that one doesn't work. 4 7s, or the coordinate 4 7 does work, as does the point 10 5. Okay? 5 is the same as 4. Which point lies on the circle? So this one has an equation x plus 2 squared plus y plus 2 squared equals, if the diameter is 10, the radius is 5, 5 squared is 25. Press pause and figure out which one of these is on the circle. Hopefully you got A. Now, last example. If my circle has a center at -4, 1, which equation could represent the equation of circle P? So it looks like they're giving me some arbitrary r squared. Since all the r squareds are the same, I'm just looking at the first half of the equation to see which one matches. So if it's -4, we know it's going to be opposite of +4. So it can't be that one, it can't be that one. +1 is going to give me a -1, which is this one right here. All right. What you're going to do now is you're going to do the quizzes. You need to get at least 80% correct. Use these notes to help you. We are going to be having like a test, quiz, whatever you want to call it, on circles. Not next lesson, but the one after that. Next lesson, we're going to be reviewing. So make sure you have all your circle stuff down, turned in any late missing assignments. And yeah, as always, if you have questions, let me know. Email me. Hope you're doing well.